John Blair to you all. I'm sure most of you know him. He's had a lot of dealings with the university and Ubuntu and Red Location. And we've asked him to come and share his experience with using concrete in architecture. So thank you, John. The floor's for you.
Thanks. Karen, I'm going to sit a bit more in a way. Just a few words of introduction. It's not going to be a structured presentation. I'm just going to show showing pictures that I've taken over the last few years. And I've talked to the pictures. Essentially, I'm going to be talking about buildings where the concrete structure itself is the finish externally and quite often internally as well. Where you do that, the concrete structure becomes the actual finish, and the cladding, or any cladding that you would normally have had, falls away. So in theory, you're going to make your own life a lot easier because you don't have to detail the cladding. The only problem with that is that the cladding often becomes the first line of defence, so it means that in terms of your detail design, your concrete structure design, your concrete detailing and your building detailing has got to be very good. Because you've got to make sure there's no cracks and there's no leaks. My experience with clients is that once the client moves in, he may phone you, but he's not going to phone you to say how wonderful the spatial areas are that you've built, or how wonderful the planning is, and it's made his life a lot easier. He's going to phone you and he's going to say, there's a crack in the main conference room. And it always happens in the main conference room, it never happens in the store. Or alternatively, he's going to come along and say there's a leak right at the front entrance, as there was at Ubuntu, and it's dripping on the guys as they walk in through the front door. That's what tends to happen. So your detailing has got to be as good as it possibly can be. I think the thing that we need to bear in mind when we're doing concrete construction like this is that what you're going to finish up with is a reflection of the shutter itself. So if you leave a nail inside the shutter, you're going to get a hole in your concrete. It's as simple as that. So what one needs to do is to make sure that your shuttering is as good as it possibly can be, and the concrete is as good as it possibly can be, because those are the only two variables that actually occur. Okay, I'm going to show pics. I'm going to talk to the pics. The pictures I'm going to show are mainly Ubuntu, which is in Sweden. That was built 2008 to 2010. But I'm also going to show some of NMU, the main campus area, which was built in 1970 and 1979, 9 years on. I'm going to show some of Red Location, which this is, which was 2003 to 2005 in the museum. And then I'm going to show some of the Art Gallery and Library at Red Location, which was 2009 through 2011. I've grouped the pics, and I've grouped them in sort of show finishes initially, or what your actual options actually are. And then I've gone through the construction of the building, and the foundations, piling, as it was in Ubuntu. Then I've looked at how the shutters actually lift with the building as it goes down. And I've got photographs showing details of various shutters. I've got some details about placing how the concrete can and should be placed. And then I've gone to first floor roof construction, and then I've searched hard to find some defects. Difficult, but I've managed to find a few defects. And we can show how we can actually solve the problems on occasion. So that they are grouped, but please, if you want to ask questions as we go ahead. Don't ask a detailed shuttering question when we're looking at finishes, but it's much better if we have a dialogue and go backwards and forwards than I just talk. Okay, let's look at the question. This first one is at the Red Location, 2003. The shutters that we used here were plywood shutters. I assume that I think they were SA plywood. Today they're probably Chinese plywood, but it's straight plywood shutters. And the shutters themselves were purpose-made, a lot of it on site. So there's a shutter for the column, there's a shutter for the beams, and the struts, it's plywood with timber struts and so on and so forth. The quality obtained was actually very good. quality of concrete that SPT put down was extremely good, and generally throughout the process it worked quite well. Okay, this is a step forward in a way, and this is the art gallery replication. What was used here was plywood shuttering, but it's got a phenol resin face to it. It's a peri-phenol resin face ply, and that gives you obviously a much better quality finish. Whereas the concrete is as good as it should be. You can get ply finished with the phenol, or you can get it finished with melamine as well, which is another alternative. That's the finish that you're going to generally achieve. That's inside the art gallery. It's just, I think we were just about finishing the building at that stage.
So John, the curvature of the roof, is that a concrete too?
Yes, I've got a shot showing how that was actually done, and we'll come to that.
So that's an off-shutter finish, that wall. The previous, I mean, that looks like super fine.
Well, that is, the wall on the left is drywall, so it's not that good.
And the one on the right?
The one on the right, that's plaster and paint. The concrete structure you can see basically is the grey.
Okay.
That's at Ubuntu, and that is peri shuttering again. So that's got the phenol resin finish to it. That is metal shuttering. That's at those are V-shaped rounded columns at the art gallery, and they couldn't really be done with that curvature with the plywood. So that's you can see the metal shuttered further on. I think that's probably grease stains, but it came off pretty well. And you can see the finished article there on the left.
Is this all self-compacting concrete?
No self-compacting. They actually were going to use self-compacting for those curved top sections which we were going to deal with. And what they found was that well, as you know, as you pour it all in one go, there's a huge pressure at the bottom. So in the end, they didn't use self-compacting because you could get it all in, but they couldn't produce a shutter that was strong enough to contain it. Okay, that's at NMMU. I'm just showing the ceiling finish there. That's metal. All the shutters at NMU are metal panels. The ceilings were off shutter, straight out of the shutter. All they did was rub down slightly and remove any excess concrete that had come through the joints. And you can see there, you can still see that there are space blocks you can still see. But generally that's taken 40 years later, so it's not actually done that bad.
Why is there that different colour in the one panel? Because I mean that would have all been part of the same concrete batch, wouldn't it?
Yes, but you're going to get different colours you're going to get different colours, different...
Is that from the shutter?
Yeah, even from the shutter. Which one do you see?
Shutter oil and stuff.
Oh, you can get shutter oil.
John, I asked exactly that same question in 1973.
Yeah.
And the answer I got was actually the shutter release agent they'd used.
Well, shutter oil on all of it, yeah, okay. You do get differences. Well, you'll see it on Ubuntu. You get differences in different times, and you get differences depending on the humidity and so on. But I mean, obviously, that's all tested at the same time.
Yeah.
The glass there is structural glass, which is regulate, which used to be made in PE. We were going to use it on Ubuntu, but we found that it was only now manufactured in Egypt. So it's the only place in Africa you can actually get it. Okay, that's anthropology. And what was done at NMU was that the metal shutters we used, the joints in the metal shutters were sealed. You can actually see where the joints are. And the finished walls were then bush hammered. Now, bush hammering gives you a texture, but it doesn't hide faults. It actually, if anything, makes the faults worse. So you don't bush hammer just to get rid of your problems. You actually bush hammer just to get the texture. The joint there is at roof level and at column position. What was done at NMMU was we expressed all the bolt holes. Now somebody somewhere decided that they were going to fill all the bolt holes. I don't know why they decided they were going to fill them. I don't remember, certainly in the first 10 years that I was aware of, there was ever any water or no moisture penetration through them. And they obviously forgot in some instances, and the bolt holes are still there. I don't believe there's any leaks through them. But at some point somebody decided to fill all the bolt holes.
John, what do you mean by bush hammering? I'm trying to picture it. I haven't seen it, so I don't know.
Well, it's a hammer. I think it's got two. The one that was used at NMMU was a double hammer motion. It was double, and it was worked by compressed air. So it's just hammering like that.
But a man with a...
Yes, you've got a compressed
You do a whole...
Yeah, you just simply do it. I think Professor Smallwood wants us to go into the Hague court because it's not the most ideal thing, bush hammering, because you get cement dust. But I think the last firm to use it was NOH, so I'm in good company. Because they used it at the New Brighton. The Memorial in New Brighton. But it's used by compressed air, so you've got a double hammer. I mean, you could also do it by blasting. All you're doing is removing the fines, or the top surface of the fines, so you can remove 4 or 5 millimetres of it, 3 or 4 millimetres of it. That's all you're doing. I think even in the 70s they did in fact wear protective material, which was pretty good for the 70s.
John, what you're saying, normally these sort of finishes doesn't necessarily have perfection.
No, it doesn't.
So it actually can express it.
Yeah.
So you need to be careful just
I mean, you can see the line, you can see the joint line there. So it isn't there to hide. It isn't there to hide the problems in the concrete. Let's go back. The idea at NMMU was that our architectural idea was that the slabs were basically floating slabs, and then in terms of the vertical depths or the vertical lift shafts or staircases, they were done with IBR shuttering, and then somebody comes along with a hammer and drops all that down.
John, if I could just ask you something. A student actually asked me yesterday how the shutters were made, and my answer was IBR. But did they use genuine IBR, or was it a special profile?
It's ordinary IBR profile.
Was it ordinary IBR profile?
And then you'll get bolt holes in there, and then they're obviously filled. But they're pretty good. You struggle to find out where those bolt holes actually are, and you just fill them out. What we did at NMMU, we did have a patching process where we got various mixes, and we put them out, and then if there was a problem, something had to be patched, then we could say, well, the mix closest to that colour is whatever it is mix, and then you would use that to actually patch.
But that IBR must have been quite reinforced on the outside with a lot of...
Well, it's very strong in itself.
But for a big panel like that, I can imagine bulging and distorting unless it's quite...
well, it's up to the contractor to actually come up with an answer. Maybe he's got the engineer will probably might help him, but IBR in itself is pretty strong.
But it's flexible.
What we did at NMMU generally, most of it was negotiated. The first section, anthropology, education, main building, library, was all negotiated on scheduled rates. So we were able to bring in the shuttering subcontractor at day one. We were able to work out the joints and exactly where the preferred joints were in terms of construction, in terms of shutters.
And they could reuse it?
They reused it. I don't know what the number of reusers, but there was, can you remember one? They got quite a few stretched at Okay, as I said, we generally, the process was that we would have the floating slabs at floor level on the roof level, and then we get the vertical section expressed in verticality. The only precast work at NMU was the handrails and the supports for the handrails and the gargoyles. We did look at doing other areas of precast, but we've struggled with precast in Port Elizabeth just about on any building. We tried to look at precast at Red Location, and we didn't succeed. And we've tried various other thoughts. Also on Relocation, Relocation Museum, we looked at precast for the large rooms, and we looked at precast for the roof sections in the art gallery. But in both instances, we've gone back to in situ.
John, how are those fixed? That's a detail I looked at a lot wondering about that.
What fixed?
The support, and then the support to the handrail and the handrail onto that support. Is it just a pin?
Gravity.
Yeah,
I think it's just a steel pin.
I think it's just pinned and grouted, yes. They're pretty heavy if you try and lift them.
Yeah.
You won't lift them.
Thank God for gravity.
Yeah. They haven't, most of them haven't cracked. There's been a couple of cracks, but of course you've got to just watch the cracking there, because I don't think there isn't a soft joint there.
And for the size of the member, that's not a huge piece left over in that joint. Anyway, so it's
Well, it's rebaited in.
John, the parapet wall and the spandrel panel on the main building, were they second cast in situ as well? That joint?
Yeah, the joint they cast up to, that
That's the
joint
slab.
there is slab level.
Yeah.
So they cast up to slab level.
And then cast the wall on top.
Yeah, and then they cast the wall on top of it. What we actually had there was a weather bar in between. Our engineers at Ubuntu said we don't need weather bars, so we didn't put weather bars in, and you've basically been proved correct. I mean, there's no water penetration or anything. But at NMU we had weather bars bent back, and then they brought them out when the next cast was put in. Okay, as I said, you're still going to see, even when you bush hammer, you will still see the joints, the joints in the metal shuttering. But generally, your eye doesn't see those joints. Your eye is going to basically see the overall form rather than the joints. But you can still see them. But this again is taken 40 years after it's been cast. You don't get as much pollution probably at UPE as you get at Sweden or in Relocation, because you're the right side of town. But still, it's lasted pretty well in 40 years. The equivalent buildings were those done in Golden Becky Avenue, municipal buildings. Those were all done at the same time, and I believe that this has lasted better. Okay, I don't know how many people have seen that at NMU, but you've all worked through it. That was a sample of the casting for the retaining wall outside the main building, and that's polystyrene. That was a sample or a mock-up that we got, and just here was the main site up, was just where the photograph was taken from. So they produced that and put it outside, and we said okay, and then they went ahead and cast it.
What do you mean that's polystyrene?
It's polystyrene. The shutters are lined with polystyrene. Somebody's sculpted out with a knife.
So it's reverse, yeah.
Yeah. So I mean, you can do anything you want. Right? I mean, you could put Pirelli rubber floor on the inside. You can put anything you want on the inside of the shutter, and you're going to get exactly what you put there. Okay.
Sorry, John, are you moving on from UP now?
I am moving on.
Maybe a quick, it isn't about the concrete work per se, but were there any, and I know it's a time of awards and things one way or whether that's, but were there any awards given for the NMMU building?
No.
Were there no
None at all that I'm aware of. We got an institute award for Santam, which is now Santam, is it? Or whatever it is in Golden Becky. But that's the only award that I'm aware of that we got at that stage. You didn't get anything from the institute before.
I'm just wondering the institute and beyond, because I think it's an absolutely remarkable piece of work, and just from a as a modernist piece, it's iconic, and then the integrity to the ideas through to the detailing is remarkable. So, and I'm not aware of any
No.
of
I
that.
think we were incredibly lucky to get that building, to be able to do all of those buildings. And I think this is one of the things with the relocation as well. If you can get continuity throughout all the buildings, it's a huge advantage. At Manchester University, there was literally no continuity. I was working there in the 60s, and they gave us just after we finished it, they gave us a palette to work to. I was working for Sherry Hicks at that stage, and I did all the drawings. I was junior, so I did all the drawings for, or most of the drawings for the mass building there in University of Manchester. And that building was demolished in the early 2000s, and the reason it was demolished was that it wasn't fit for purpose anymore in terms of education, because maths has moved on. There's been things called computers. And when we designed that building, it was designed as small seminar rooms and so on and so forth, and it was a tall tower. It also linked to the system of the 60s, which was everybody's going to have a first floor walkway, as we had in Main Street. It never happened. And it was the first section of a walkway which was going to span from the university to the city centre. So that building was not fit for purpose because it didn't suit the new math system, so it was actually demolished. Although I think it did get awards, and it was regarded by the architectural critics as the best building at the University of Manchester, but it got demolished because of that. Now, what we did at UPE was we had the planning was essentially for the buildings themselves was universal space, because each building you could develop it any way you wanted. It was always drywall inside. The library is the case in point, and the thing is that those buildings are still fit for purpose because they were universal space. So it did work in that effect. I mean, the main building when it was built had a lot of faculties in it because you couldn't administrate yourself. So a lot of the faculties actually moved out of the main building into other buildings.
John, sorry if I may, your choice for going to concrete as a wall finish for the campus buildings. I guess two things. Firstly, life cycle cost in terms of spalling repairs, which we all know that have taken place over the years, compared to, for instance, having put a plaster render and painted the buildings. And secondly, was that decision part of the thinking around the architectural statement that you wanted to make? Would it have been a lesser building, I guess?
I think it would. I think it's given continuity over the whole campus. I was involved peripherally when I first joined in 1970 with the basic planning of the university, but I got in at the end. Essentially, I think it was a decision into plan from the early 60s was involving concrete buildings. CSIR out there was done first, so there were other examples around town. So concrete was something that they were involved in from their inception. So I think that, but the guys did go to, they went to Hawaii, they went to the States, they looked at quite a lot of concrete buildings there, and the intent was always concrete. But the planning I think has generally worked. One of the problems, what we did in terms of at UPE with the air conditioning, we had all the buildings were air conditioned with the central plant. And I think everything was designed up to in the early 70s. Now there was a giant increase in oil costs in 73 and another giant increase in 79. The university didn't get the increase in numbers, which is no doubt reasons for that, but they couldn't afford to carry on paying for the aircon with the cost of oil as it was. So basically they took out all the pipes, sold them presumably for scrap. That was probably not the best idea because there's been advances in air conditioning since then, and if we kept the pipes, they could have actually, they could probably have got the air conditioning back in the 80s or certainly in the early 90s as an economic situation. We did on the sciences box look at using split units, and had we done that, the sciences box would probably still be have air conditioning, but now they've just got the odd window rattlers that you know. The importance of mock-ups, it's very important to do mock-ups wherever you can. Wherever your building you're able to do it, please just remember to do it. This was the mock-up for Ubuntu. You can see in terms of the finished article that we reduced the size of the joints, and we reduced the size of the ferrule holes. We repositioned them. What that did tell us is that we got the size of the gun poles right. And you're never sure on a drawing, you're never sure on anything that you draw. When you go and stand behind them, you can see that's the diameter that we're okay. The quality of our concrete, I think we've improved when we got the building. Okay, I'm now going to talk foundations, and that will go up the buildings as we proceed. This is replication, and it is the art gallery, and you can basically see on the right the standard type of foundation you would get for a column. So that would normally be a base, and that would be normally how you would build the building on that basis. If you've got walls and columns, then you normally have, you can see at the bottom here, you will normally have a beam, an edge beam, which would span between the bases. And the way you would go, you get starter bars, you can see starter bars there for a wall, which are going to sit, on the base. And then you come along and cast the walls afterwards. At 3D, we had background conditions, we had heaving clay, what we thought was soft clay, and what happened there was we got piles, auger piles, as you can see the auger, and we actually cased them with metal casing. At the top of the pile, that's the pile as it's cast, and what you're doing at the top of that pile is you're going to cut those piles back, trim them back, and you're going to form pile caps, and those pile caps are exactly the same as the base for a column. So you're going to form pile caps as the shuttering quarter caps, and essentially the bases then sit on top of the piles. You cast the bases, you put your steel in the bases so that they're going to take the columns or the walls that are coming out. So it's the same principle as doing over in bases with beams. Okay, I'm looking now at shuttering. This is shuttering for the Red Location Museum. As I said when I was explaining the finishes, it's plywood, it's purpose made for particular columns or particular beams. And you can see at the bottom there's actually a strong channel section all the way around it. And as you get higher up, you don't need it because you're going to pour the concrete from the top, and the pressure is at the bottom, so that's where the problem is going to occur. It's going to be a problem. They initially tried just doing it in timber, and they found that when they poured the concrete in, the pressure was too great, and they then went ahead and put the steel channels at the bottom. We didn't have mock-ups in this instance, but we were lucky in that we could cast the columns and so on well down in the ground, and we used the first casts as basically as the mock-up for the museum.
Sorry, John, on the shuttering, what you call those vertical, did you call them braces?
Well, I suppose those are braces, yes. The horizontal members are called whalers.
Called what?
Whalers. I'll show you those as we get on. At Replication Museum, we've gone. Sorry, not museum. At the art gallery, instead of using ordinary ply, here we've used the phenol resin coated ply. There are the ply. There are the shutters. They are a step forward, I suppose, because they're not built for that particular column. They're actually a paired system which has been used. And you can see the quality of the concrete there is probably better because you've got a better quality shutter. Perry also come up with a whole process of supports which you can just buy or lease or however they work it. At UPE we had metal shutters, but the builder had to work out how to support because the systems didn't exist in those days. At Ubuntu we're using a different crane, dropped in position, undo those bolts, tighten them all up, and away you go. And those climb. And as the building goes up, they climb, and they climb, and they climb. So there's a cycle that you get into. Eldred, I can't remember I think the cycle was 3 weeks, something like that. You'd have to, you cast, you strip. How long would you have to wait before you bring the next shutter up?
Very quickly, not now, but they have all the time.
Yeah. So it's a
I
very,
don't remember the exact.
I think the process was like a 20-day turnaround from the casting the one to casting the next section.
What's the reuse rate of the shutters normally?
Sorry?
The reuse rate of the shutters?
As many as they can.
So there's no specific, you want new shutters for every fifth
I don't know,
port.
Eldon, would you
It
know?
normally depends on how big it was finishing.
If
If
you
you want
want,
very good finishes, then like 2 or 7. Finish doesn't matter.
That's why it's better to use the metal or the ferry. But I think we generally the thing is we have three. I think we had 3 sets of shutters at Ubuntu. We're operating at any given time. Okay, in terms of supporting shutters, the support work the builder's got to work out. He's got to work out how he's actually going to physically do it. In the case of the art gallery, they actually put in gangnail trusses, which are then sacrificed. To me, in a way, it's an archaic, but it's a very archaic way of doing it. Okay, the Pantheon was done like that 2,000 years ago, but it is an economic answer, and it's an answer which gives you concrete, which, apart from still going 2,000 years, then presumably this also will still be going 2,000 years. But it's quite a structure as you're building it. You can see the process.
You're able to reuse some of those trusses.
I don't know whether they are.
Sacrifice.
Yeah, they probably did because they
Move them in sets.
you do a section and section and section. I can't see them. I never asked them whether they did. Okay, your support work, doesn't matter where you're operating, you've got to support it. Those top beams, this is the museum, top beams we did look at precasting, but there just isn't the tradition of precasting in Portland actually to be able to do that sort of work. And the support work can get quite hairy. What happens here, what happened in Ubuntu, the walls themselves were not self-supporting. So in terms of the hall, which this is, it only became self-supporting when the roof was cast and when the roof was post-tension. So until such time as that roof is post-tension, those walls have got to be supported. And there's a fair amount of support in there. In actual fact, what they used the props, it is 45 degrees, and those props were supported on concrete strips, and those concrete strips were themselves then used as a basis for the ground floor, and that was cast. As you can see, but it's quite a performance when the wall itself is not self-supporting.
As the architect, how involved did you get with this whole, did the contractor discuss this whole methodology with you?
No, I don't know whether they did with it. No.
I mean, you talk about the strips in the floor being used.
Look, the methodology is essentially his. What we did with Elisa and the contractor is we sat down with Perry, with the shuttering guys, and we detailed our construction to suit their panel sizes and to suit their system. But it's up to the builder to actually design temporary sizes.
Engineers and design systems.
So obviously the engineer said to him, this wall's not going to stand until you've post tension. I mean, there must have been like an assembly instruction from the engineer.
No, but the walls are all skew, so
Yeah,
he was told he had to prop this walls until the whole body was built.
brutal engineer.
But it's his decision. He's the guy that's actually got to do the temporary works. So you don't get involved and say, we're going to instruct you to do this, that's what you're going to do. But I think you did give them loads and so on, so that they were able to then do it.
So I think that's one of the issues, I don't know if it's John Small, that architects have to think more about how something is going to be built these days.
Well, you haven't
They
changed
get-
his speciality being H&S. You are responsible in terms of H&S, or the engineer is also responsible in terms of H&S. That the building mustn't, you've got to design the building so that it can be built.
So John, when you tender this project, I mean, if you've now talked with Perry and you're detailing according to a Perry system, presumably you then nominated them as the shuttering scaffolding supplier.
I think we actually asked the contractor who he was going to use.
Oh, I see.
But it was a negotiated contract. You see, having a negotiated contract is ideal for this
I
stuff.
think that's the key to the success of this
Well,
process.
I think it is. Although, let's say the revocations were not negotiated because they're municipal, but we used SPT revocations, so they'd gone through the process and they knew what they were actually doing. But a lot of UPEs were also negotiated.
Wasn't the issue also if we specified periods of being more expensive, so we had to let him decide to use period?
Yes, he must
Was
decide.
that an issue?
Yeah, absolutely,
If we
because there's-
specify a period of the cost of
Yeah, but now if you're going to detail this, thoroughly pre-tender, and you're not going to nominate systems, then I can see it will require an inordinate amount of work to actually
Yeah, a lot
put a document out.
you're tendering on schedule rates, so your detailing can follow.
But the period system was used more because of the finish,
Yeah.
because that's what we thought would get the best finish, but you couldn't use any other system.
Yeah, there are other systems available. But again, the guy is tendering on schedule rates, and Harry actually does it to him, but we took the advantage of the fact that we could talk. Look, you could talk to Terry in the traditional basis. Yes, you can talk to Perry and you can nominate. But you don't want to nominate if you can possibly avoid it, because then you're going to start trying to be involved in paying.
I think the QS was very clear on that we mustn't instruction about
Yeah.
it or something.
It's just this, sorry, I don't want to belabor it, but your expectation of off-shutter finish versus someone else's, so how does one then specify that in the document so that you know you're going to get what you're going to get and not what the builder thinks that you want to get?
Well, that's why you have mock-ups.
But you can't do that before you tender the project. So in your document, you need to say that you will tolerate X variance or imperfection.
Well, the SABS has got all these variants and all the rest of it, but at the end of the day, it's at the end of the day, the problems, I'll show you, the problems are going to be either the shutters kick, or you're going to get honeycombing, or you're going to get air pockets.
I think with this instance, the contract played a big role. If you didn't have this contract on site, I think we'd have had a bit more difficulty.
We'd had a big problem.
Without this contract, you were able to...
But we did the same thing at UPE. We sat down with a subcontractor and said, these are where the holes are going to be, and we talked to the engineer at that stage, and we worked out where all the weather bars were, and so on and so forth. So the fact that you negotiate does help, there's no doubt about it. You can't always do it, of course.
If you want a high-class finish, that discussion at the stadium as to what the in-situ finish was. A lot of pre-cast elements of the different story, but the columns were in-situ slab. Eldred, there was a class of concrete that was intended.
But there, we were just lucky the guy built very concrete. We didn't
lucky there.
specify very high cost finish. We just built
But
very
you can
concrete.
specify a higher finish than
You
it was.
can.
But you pay for it.
You pay for it. But
Yeah,
in this instance, we were just
I
very
think
much-
we had 5 levels of different concrete in the build, and we described them
Of concrete finish.
concrete finish. Yes. So
So you can specify the smooth phase board.
but at the end of the day, you need to do the mock-ups.
You still get that.
It's still up to the individual. Okay, let's get on to placing because we're going to run out of time. Generally, placing these days is done by pumping. It's the best way of doing it. It's the fastest way. It's the quickest way, and you can get much more volume of placed using pumps. The whole of NMMU was built with tower cranes and with skips.
There were no pumps there.
No pumps, no.
That's it.
So it all skips and tower cranes, and you had to work out where the builder had to work out where all his tower cranes were, so that it's quite an exercise. It's the system in terms of pumping. We've got a pumping truck which comes along with a pump and the boom, and that sets itself up, and then the ready-mix concrete truck comes behind and deposits it into the pumping truck. The pumping truck sends it over the boom, and as you can see, there's this thing's got an ability to span a hell of a long way. But they've still got to work out where the builder's still got to work out where he can get his trucks, how he can get his trucks in, and how he's actually going to do it. Okay, then the concrete is going to come down there, and the guys are going to compact it using a poker, which is got run by compressed air. So you're able with the pumping system to deposit quite a lot of concrete in one go. Then you've got to make sure with spacer blocks that you actually keep the steel away from the front face, because your face is going to be the finished face and you don't want to see spacer blocks. So these days we have plastic round spacer blocks, where again you don't see those on the face because you just come as a fine piece of concrete. What we did at NMMU was we actually, instead of using the normal pieces of concrete, we actually cast a whole lot of pyramid-shaped blocks. And we tied the pyramids back to the steel, the wire, similar as you've got there, with the theory that the tip of the pyramid was the one that stayed on the outside. And occasionally when the poker went in, the thing flipped. So you'll see the odd thing at odd places at NMMU where you've got a nice square piece of block sitting like that. But these round things are wonderful.
So what do you see of that, John?
Sorry?
What do you
Well,
see
you
of
don't
it?
see nothing, because it's a point of plastic. Okay, the other thing you need to look at when you are casting and working on site is that you've got to protect the corners. Obviously, at Ubuntu we didn't have chamfers, which help no end, and so those corners had to be protected. Okay, that's just been cast, so you've got to strip it. But you'll see that as we progressed, all the corners up to a reasonable height were protected by timber. If you don't do that, then somebody's going to drive into it apart from anything else, and you're going to have a major problem in terms of patching. Similarly, at relocation, you protect and protect and protect. If you don't protect, it's very difficult to patch it. You'll also see there's polyethylene. The column is wrapped with polyethylene. That's to help curing or to slow the curing. We live in a very bad city from the point of view of curing of concrete because we've got two things, wind and sun. And you've got to stop that. You can put curing agents on it and so on and so forth. The concrete needs to cure as slow as possible. So we wrap it with polystyrene so that polyethylene so that protects it from the wind and doesn't dry out too fast. Okay, first floors and roofs. This is first floor at Ubuntu. You can see the blocks. Those would be the spacer blocks that you would normally use. At NMU we use pieces of concrete like that, but again, there's a perimeter. That's the first floor, and it is a junction of the first floor and the walls. This is a section. This is Ubuntu roof. You can see the steel has been placed. The spacer blocks are there. The blue are tensioning cables.
They weren't sleeved. The tension cable.
Well, the sleeve, the blue is the tension cable is through the blue. So what we arranged was that the tensioning would, when the cables come through the wall, you're going to see that exposed because that's where they're going to actually physically tension it. So what we did at Ubuntu, we arranged that most of the cables came through the gutter, and the gutter was lined with derby gum. So you can't see where all the tensioning points occurred. Although the majority of them are all going in one direction, there has to be a certain number of cross cables which we did finish up with an exposed area that we had to patch. But most of the patching we got away with because we carefully put it into a gutter. Okay, it's blowing out. It's blowing out all the dust and so on. So it's fairly technically advanced. Okay, then the roofs at Ubuntu, Power wanted them concrete, so they are concrete. And the concrete finished itself and power floated. And we haven't had any water penetration because they're post-tension, so in theory there is no stress.
So no waterproofing on top?
No waterproofing. There was a waterproofing additive added to the concrete, but apart from that, there's nothing. That's the finished article.
John, maybe a silly question, but concrete being porous as it's wet, how do you keep it from not slipping? Because that was a question that was asked previously in the discussion I had.
Well, it didn't slip. I mean, it's not that steep.
Yes.
And you're trying to put it in as dry as you possibly can. And you're having admixes to make it workable, but at as lower water content as you possibly can. So it didn't slip away, did it? It's still there.
So shrinkage cracks are managed through the additives that you put in the concrete?
Well, they're managed because it's post-tension. So in theory, there isn't a loading on it. One of the things that you need to remember if you're doing off-shutter concrete work, and really this is number one, you've got to A, keep the movement joints to a minimum, and B, design movement joints so you can seal them. Because movement joints are where you're going to get the water penetration. We finished up with only one movement joint at Ubuntu, but you've also got to try and detail them so that they're only moving in one direction if you possibly can. If you get them moving in two directions, you can't see them.
As I understand, post-tension units, it puts the whole structure into compression, so any shrinkage is just absorbed in the compression, so you shouldn't get any cracks at all.
Yeah, that's the theory.
You don't post
The
it.
theory. we got very few. We got one crack.
And the crack that happens sort of seals itself. Concrete tends to heal itself down.
Okay, what can go wrong? Go wrong. You can get air entrained. This you can see the holes there. That's entrained air within the shutters, and it presumably hasn't been properly compacted. It's very difficult because what happens is that, particularly when you've got sloping walls, the air can't get out. So you're going to get the same sort of thing happening here. And you're going to compact with poker, and if you don't get all the air out, then you get holes like that, which is entrained air, which hasn't actually managed to get itself out. They actually investigated using polytetrachloroethylene, PTFE, coating on the shutters, but it didn't make any difference. So we went back to ordinary shutter oil, trying to make it slippery. But it goes down to mix, and it goes down to proper compaction. Usually those are the two things that you've got to get right. That's also entrained air, and you see that.
What did you do about it in the last slide? To take that off and recast?
No, I'll show you I'll show you what you can really do if you really put your mind to it. You can get epoxy fillers, but no, which we didn't have at NUU, which are very good and non-shrink, and actually you can match pretty well. But they need somebody to apply them that knows how to do it. Well, now you can see what they call the honeycomb. Okay, so what we've actually got there is between each cast, you're going to seal off with a sponge like, I don't know what it is, but it's a sponge that seals one cast and the next. Now this is quite classic, it shows exactly what happens. If that sponge doesn't work, then the concrete from the top cast runs through into the bottom cast, and there it sits. Now if you take a bolster to that and just plop it, it will fall off. But you still sit with the honeycombing at that point. So now we know why it's honeycombed.
So how did that slide down?
Because the seal didn't work. You've got a seal, you can see the seal, you can see where the seal is running all the way down.
Split space.
Okay, now if you really get into trouble, and the other thing that can happen is the honeycombing, the other thing that can happen is that the whole thing can slip. And you can get a shutter that moves out. You can cut back, and you can fill. Whoops, wrong way. There it is, fill. But bear in mind, that's on a roof, it's not exposed, it's facing north, it's protected from the north, southwest, and it's protected from the southeast. If it was at the main entrance, I wouldn't do it. Okay, the other thing that can happen is that you, if you don't, stop it, I'm not pausing. Yeah. If you don't place by pumping, then what happens is you place by skip. If you don't get it done in time, well, that's supposedly one cast. One day they didn't get the pump, they couldn't get the pump, so they decided they would do it with skip. And that's the result. So pumping, you can do a heck of a lot of concrete in one day. Skip is more difficult.
You're talking about the blemish.
Yes, I'm talking about that line. You can see they've actually cast to a point, and then the skip's been somewhere else to bring the skip back. And the pump enables you to not have that situation.
Half an hour later and it's already got cured.
It's already started curing. You can see it there. Now we've got a different colour there on that band. Now, I don't know what that is, whether it's just the mix at that particular time, or whether which would all have been done in one go, or whether it was the humidity at that particular point, or whatever it was. But if you see the cast above, you can see the baggers used to skip there and didn't tell me. So that's the result. I see it. The majority of people won't see it. No, you'll see it whenever you go around the building you'll be looking for it.
Quite artistic.
One day you got that great finish.
Yeah. Okay. Right. I'm going to finish just with some photographs I like taking. I get a lot of joy out of building these buildings because you actually see things when you're building them that you don't see in the finished article. The finished article, unfortunately, has got to have things like waterproofing, it's got to have glazing, it's got to have floor finishes and all the rest of it. So when you're building it, you actually see, you're able to do shots like that, which you don't see at the end of the day. This, for instance, this is the library. These are sunscreens. But again, you see these shots while you're building it, but when the thing is built, you'll never see that again. So, similarly.
Front with right stuff there.
Yeah. And that's cool. That's in the library. Those of you who are old enough, which, yeah, okay, Graham, will remember Corb and La Tourette. You remember La Tourette, presumably. But his La Tourette did a lot of the monk's cells. He used that to been used in the library.
Where is that, John?
That's in the library at Red Location. Okay, one of the things in terms of the Red Location Museum was that the intent was that the building should reflect what was around it. It should echo the industrial motor manufacturers and so on around, and it should be sympathetic to what was being built in the township, which was generally concrete block. I took that when we were sort of halfway through 2004, and again to emphasise the fact that it's actually at one with its surroundings, because you can't see where the surroundings start and where the building finishes. But when the building is complete, you don't see that to the same extent. I'm not really even tempted to flip that as a bit could. Okay, that's that's Education Museum. But again, just to show that you don't, when you go to the building now, you don't see the structure that you're going to see at that point. So as it's being built, you see all sorts of structure, and it's uncluttered with architectural supports, glazing, roofs, and so on. So you get some.
I'm amazed at that beam. It's only sitting on about 100 at the top of that column. Is that right?
It's cantilevered from the other one.
But this span is really long. It's more. Can't be. This span is
Yeah, well, this comes about 250, 260. But I'm not quite sure how. There's another. The beam itself is running like through it.
So there couldn't be steel going from the column
There's
into
there's a odd bit of steel at the top there, Carl. Don't worry. Okay.
Yeah, that's a very big span. I don't think.
Well, those are the things we were thinking of doing in precast.
No offence, Albert, it just goes to show that you can be quite light-handed when you want to.
Well, you can be very light-handed if you without the infill. That's why it looks so wonderful when you're building it, other than having to drive and seeing a thing going up.
I'm just wondering about this propping. What if there had been really heavy rain and all the heaving clay decided to heave, or was that all excavated and supported?
I didn't have any sleepless nights about that. We had a drought for 2 years. Yeah, again, you won't see that. You won't see that shot again. You only see that shot as we're actually being built. And then you see other things. Okay, that's it. Any
Lovely.
other questions?
Any questions for John?
What would you have done if that slid shutter had been at the entrance, taken down both panels?
Yeah.
Because
Yes. Yes. So you've got to, you try not to have to knock things down if you can possibly avoid it. If you can let something through, which doesn't affect the client, doesn't affect the contractor, but saves him money, it's to your advantage because that's one for you. So that when you made a step up, no one sees that. So I mean, the contractor's got a lot of problems. It's not an easy task.